In this video, we're going to take a look at bar charts. At SL level, all the bar charts that you come across will have equally spaced bars, and they will be drawn against frequency. You won't come across any bar charts where frequency density is involved. So, what is a histogram? Well, histogram is basically a bar chart for continuous data. So if you look at the histogram that's been drawn, it is battery life against frequency. So if you look along the x-axis, which is battery life, it goes from 400 to 500 to 600 to 700, all the way up to 1300 minutes. The y-axis is frequency, so between 400 and 500 you have a frequency of 3. Between 900 and 1000 you have a frequency of 27. If you go back to the frequency table, it's group data, and as you notice, the lower bound here is the upper bound of the previous. So 500 is included here and not here. At SL level, you're very rarely asked to actually draw a frequency table. You might be asked to draw a histogram. You might be asked to fill in one value, so this value might be missing here, and you'll refer back to your histogram and fill in the frequency here, and you might be given this frequency and be asked to draw this bar in. But you very rarely, because it's time consuming, not asked to actually draw a full histogram. Let's look at some typical exam questions you might be given. So question 1. The given histogram shows the number of hours that students in a particular class had slept the night before. So there we've given our histogram with time along the x-axis, frequency on the y-axis, and question A, we are asked how many students are in the class? Well, we need to add up all the bars. So we got 1 plus 3 plus 8 plus 10 plus 3. So we want 1 plus 3 plus 8 plus 10 plus 3, which gives us 25 students. B, how many students had at least 8 hours sleep? Well, at least 8 hours sleep is 10 plus 3. So we want greater than or equal to 8 is equal to 10 plus 3, which is 13 students. And question C, what percentage of students had less than 6 hours sleep? Well, less than 6 hours sleep is this bar plus this bar. So it is 3 plus 1, which is 4. And we want 4 out of 25, which is 16%. Question 2. The following frequency table shows the data distribution for the length of leaves in millimeters collected from a species of tree in the botanical gardens. Question A. How many leaves less than 60 millimeters were collected? Well, less than 60 millimeters is this group plus this group plus this group. So therefore we have less than 60 is equal to 19 plus 11 plus 5, which is 35. Part B. What was the most common interval of leaf length collected? Well, we're looking for the modal class. Well, the modal class is 60 to 80 because 49 students were involved. So the modal class is 60 less than or equal to x less than 80. Part C. Are leaves more likely to be at least 60 millimeters in length? Well, at least 60 millimeters in length is 49 plus 43, whereas less than 60 is 19 plus 11 plus 35. So greater than 60 is equal to 92, where less than 60 is equal to 35. Therefore, the answer is yes. Part D. Can we conclude from the table that there were no leaves collected with a length less than 5 millimeters? Explain your answer. Well, any leaf with a length less than 5 millimeters would be in the first group, which goes from 0 to 20, and there are 5 of them. We don't know what those lengths are. There could be 5 that are 1, there could be 5 that are 10, or there could be a mixture of them. We have no idea of telling what the length of those 5 are. So the answer to D is no, because of grouped data. Question 3. Infant mortality rate is measured as the number of child deaths per 1,000 births. The infant mortality rate was measured in a number of countries and the results presented as a frequency histogram. A. State the following class intervals. Well, if you look at this histogram, we are given the mid value of each bar. We're not given the lower bound and the upper bound. That is what we have to work out. So the first mid bar is 2.5, the second midpoint is 7.5, 12.5, and 17.5. That means there are 5 units between each midpoint. So that means each bar is 2.5 wide either side of the midpoint. So if we had to write these down, the first interval would go from 0 less than or equal to x less than 5. The second interval would be 5 less than or equal to x less than 10. The third interval would be 10 less than or equal to x less than 15. And the final fourth interval would be 15 less than or equal to x less than 20. Part B. How many of the countries recorded an infant mortality rate below 5? Well, below 5 is this bar here, and this goes up to 3. So the number of countries with an infant mortality less than 5 is equal to 3. Question 4. The histogram below shows the weight of kiwi fruit, each measured to the nearest gram. So we've got the weight along the x-axis and the frequency going up the y-axis. And we have the middle value for each group in the middle. They're only group size of 1 because it's measured to the nearest gram. So write down the modal weight for the kiwi fruits. Well, we're looking for the bar with the highest frequency, and that is a frequency of 10, and that is for a weight of 77 grams. Part B. Find the median weight of kiwi fruits. Well, the first thing we've got to do is find out how many kiwi fruits were measured. So if we add up the bars, so B, the bars are 3 plus 4 plus 6 plus 5 plus 6 plus 10 plus 9 plus 5, which comes to 55. So the median is 55 plus 1 divided by 2, which equals the 28th kiwi fruit. So if we look for the 28th kiwi fruit, we've got 3 plus 4 is 7, plus 6 is 13, plus 5 is 18, plus 6 is 24, plus 10 is 34. So it is a weight of 77 grams. Part C. Write down two inequalities that represent the weight, W, of a kiwi fruit that is considered an outlier. Well, we have two formulas for the outliers, and they are, the lower outlier is Q1 minus 1.5 times IQR, and the upper one is Q3 plus 1.5 times the IQR. So the first thing I need to do is find the IQR. Well, the IQR is equal to Q3 minus Q1. Well, I need to find where Q3 is. Well, Q3 is 3/4 times 55 plus 1, which is equal to the 42nd kiwi. And if I look for the 42nd kiwi, Q3 is equal to 79. Q1 is equal to 1/4 of 55 plus 1, which is equal to the 14th kiwi. And if I look for the 14th kiwi, Q1 is equal to 75. I can now work out the interquartile range. So the interquartile range is equal to 79 minus 75, which is equal to 4. Now I can work out the minimum outlier is equal to 75 minus 1.5 times 4, which when you work it out comes to 69 grams, and the maximum is equal to 75 plus 1.5 times 4, which when you work it out comes to 85 grams. So now I can write my two inequalities for outliers. The outliers are W has got to be less than 69 grams, or W has got to be greater than 85 grams.